Hey guys, here's your introduction video to coordinate proofs. Excuse me. The main idea here is simply just using a grid, using the x and y axis to represent any kind of geometric shape and do any kind of geometric proof, but using variables instead of numbers sometimes for some of the points. So for instance, very simply, they might ask you something like, draw a rectangle on the coordinate grid in a convenient way. So if you're thinking about, your grid, and you know for sure you've got to put a rectangle on here, what would be the most convenient way to put that rectangle if you weren't going to know all the actual coordinates? So like, if I gave you the coordinates, no big deal, you could put them anywhere you want. But if we don't know some of the actual values, we only know how, long the length is, or how, high it is, or something like that, we probably want to place it right on the axes. Okay, so if I place, if I start here at the origin, let's just put a point there at the origin. So that's locked in. And I want to go out a certain distance, I just don't know how much to go out. Well, I'm going to call that point, let's call it, h comma 0, some other variable. So h could be anything. I know on this grid I specifically, used a certain number of boxes, but I did that arbitrarily. It could really be anywhere. And if I'm going to go, vertically, I can just pick whatever I want. Let's just stop here, and that'll be 0 comma something. Let's call it maybe, k. The actual letter you use really doesn't matter. I try to stay away from x and y just because that's the actual variable of the axis itself. So just, little a's and little b's, something like that. Let's call that point B, and I guess this will have to be point D. So let's find point C. Well, it's got to be here if it's going to be a rectangle, right? If it's going to be a rectangle, I've got to connect it, right? And then the question is, what are the coordinates of point C? Well, I can't just pick anything I want because I've already kind of locked this in a little bit. I may not know how far out I went, right? I may not know exactly what it is, but I know it is represented by h. This distance right here is h. So that means point C must be that same horizontal distance if this is going to be a rectangle. So my x value is actually h. My y value, well, how far up did I go? Well, I went the same height up that I went here, and here I went, whatever this unit is, k units up. So that means this has got to be k. So this rectangle is 0, 0, h 0, hk, 0k, and this could literally be anywhere. All right, so it's convenient, again, use the origin if you can, use the axes if you can, and it's a convenient way to draw that picture. What if we had to draw, like a scalene triangle? Okay, so I'll make another grid. Scalene triangle, so all three sides are different, but one side we can lock in nicely. Let's use the origin again. Let's call this, I guess, E. I got to go out somewhere out here, right? Excuse me. Let's call that, and since I already used those, let's use little a's and little b's. So A0, and then point G, if it's going to be scalene, I don't want to put it in a point where it looks like it's going to make this isosceles or equilateral. So I'm just going to put it somewhere, I don't know, maybe here. So this is G. And the coordinates of G are not I can't use 0. I can't use A because that would be out here. So I guess in this case it's just going to be just two other letters. And that would be a convenient place to put a scalene triangle. So there's no real definite one right answer to these kinds of things. You just want to do something conveniently so that when you go to do the next level of this, which you'll see in a minute, it'll be easier to do. The more zeros you can use, the more things on the axes you can use, the easier the calculations become, which I'll show you right now. Suppose we want to do a square, okay? So let's say we're going to do a square. Let's try to save paper here a little bit. And the square has certain vertices that are already determined. So I'm going to draw it again. Okay, so let's say 0, 0 is on there. Okay, 0, 0. Let's say M0, just kind of like before, M0. And if this is a square and I'm using M0, I guess I need to use the same distance here as I do going vertically. So just for the sake of visually, making it visually, reasonable, I am going to count the boxes, right? 4, 5, 6, 7, just so it looks good. It doesn't have to be a 7. I could have made this, I probably should have made this a little smaller since I made my y-axis so short, but it doesn't matter. 3, 4, 5, 6, 7, and this is going to be 0, M. Okay? So these are three vertices of my square. So this distance is m, this distance is m, and the question is, where do we put the fourth vertex? Okay, we know this is a square. We know all the sides have to be the same. So however far out I go this way, I better go that same distance out this way. So that would put it right about here. And that would be an x-coordinate of m. What about the y-coordinate? Well, kind of like before. However far I went up here better be the same amount of distance that I went up here, which again is m, since it's a square. So if this question gave us 3 out of 4 of the vertices, because we know all of these sides need to be m long, well, I guess the fourth vertex would have to be m comma m. And I could have drawn this over here or down there, but I'm trying to pick a convenient place. A convenient place would be to use the origin, go out positive, positive if I can, and only explore the other possibilities if I have to. Okay, so there's sort of the next level of it. How about a right isosceles triangle? Let's take a look at that. Okay, and by the way, if you ever want to try to do these without looking at the explanation, just pause the video, see what you can come up with on your own, and then watch and see if you did it, the same way I did. But a right isosceles triangle, I'm going to again try to come up with the most convenient place to put it. I think conveniently, I'm going to use 0, 0 again. And I'm going to go out 1, 2, 3, 4. Just for the sake of drawing it, I'll put it here. But again, I'm just going to call it something else. Let's go back to, I don't know, let's go to h again. So h comma 0, 0, 0. And if this is going to be isosceles, well, if I go h out, I better go h up. So this is going to be 0 comma h. And I have myself an isosceles triangle. And now to take this to the next level, the question might become, what is the, sorry, I didn't draw that one so well. What is the actual distance of the hypotenuse? What is the length, of the hypotenuse? What is the distance between these 2 points? So that could be a question that they ask. So I know these are the same. These are both h. These are both h. And to get the distance here, I can use the distance formula. So the distance, let's call this ABC just so we have labels for it. So AC is going to be the square root. Now here's where it gets a little confusing because we don't always have all numbers, but now you're going to get to see the benefit of putting this on the axis. From, if this is x1, y1, and x2, y2, I could do h minus 0 squared plus 0 minus h squared. Again, we don't know what h is. It doesn't really matter. This could be a really small isosceles triangle, isosceles right triangle, or it can be a really big isosceles right triangle. It doesn't matter. The question is, what is the length of the hypotenuse? And it will always be this, whatever h is. So let's simplify that. H squared plus h squared, right? It's not negative because negative times negative is positive. This is 2h squared with the square root. And I can't do anything about the 2, but I can do something about the h squared, right? This is really the square root of 2 times the square root of h squared, if you think about it. This is exactly what we would do if we were doing simplest radical form. We would break it apart. The square root of h squared, that's just h. This is just h. So h times the square root of 2 is the length of the hypotenuse, no matter what. H square root of 2. So if h was 10, 10 times the square root of 2, which we just proved using this coordinate proof. So that's the power of these, is that this will sort of give you, the formulas, no matter where the actual values are located. But again, it was really convenient to do this on the axis, so I didn't have to deal with multiple unknowns. Okay, and that's why we do those setup problems where they tell you to just find a convenient place to put a figure. What if they asked for the midpoint? What if they asked for the midpoint of AC? The midpoint of AC. All right, I guess we'll use the midpoint formula. 0 plus h divided by 2. H plus 0 divided by 2. That's going to be h over 2, h over 2, done. So this midpoint here, we'll call that big M, would be h over 2, h over 2. And maybe that's helpful, when we need to do our mid-segment type stuff. Okay? So the thing I'm trying to get at here is that you can use all the same formulas we already know using variables instead of values for every coordinate. And that's what a coordinate proof basically will allow you to do. All right? Hopefully that helps. If you have any other questions on the homework, please feel free to post, and I could even make another video if I need to. Just let me know so that I can make sure I know exactly where you guys are having trouble. Okay? See you later. Bye.